All right, so this week we're starting in on Python. So we have a couple of concepts we want to look at in the textbook. We have a quiz over those, and we have a section we're going to start on Python. So the first thing I want us to do is we're going to go through once again how to install Python. So if you have a device and you want to go through that with me, that's great. On your own computer, you're already in the lab, you should have Python already installed, but you are welcome to go through and install and update to the latest version. So the first place I'm going to go, and you will see that I will refer you to this often during our class. I will say, go to python.org and look. This is the authoritative place. This is where Python lives. So everything from jobs to the ultimate guide on how it works, and in fact we'll look at several of the tutorials, but we're going to look at how to download and install it. And so I'm at the home page of Python. I'm going to click on the download link, and the download link we're going to use is actually the 3.6.4. And it changes depending on when they decide to do updates. So 3 is the major version, 6 is the minor versioning of it, and then the 4 is the latest update piece. So 3.6.4, and you'll notice that if I scroll down, I have install versions for nearly every kind of operating system I can imagine. In addition, if I really want to run this on a tablet, there are Python compilers for Android. There's Python compilers that can run on our iPads, but we're going to run a Windows installer. And so because I have a 64-bit, notice these all say 64-bit installers. So it tells you what it is, AMD 64. You'll see that x86 is that weird nomenclature that says it's a 32-bit installer. So I can click either of those to install it. So embedded zip file, the executable, or the web-based. I've had really good luck with running the web-based installers. That's the smallest download. It downloads a program that runs, and you'll see what's going to happen here in a second when I run it. It's going to open a file, and it says, all right, do I want to install this? And I'm going to say, yep, I do. And so now it's installing 3.6.4. Again, if you're using a Mac, it's a little different, but there is a Mac version, and if you're using Linux, there's a version for that also. So we're installing, because I know this computer is a 64-bit machine. Our programs we're going to create are small enough that it really doesn't matter. If you want to run the 32-bit, you can run the 32-bit. Makes absolutely no difference. So it should be installed in about a second here. And it says, yep, setup was successful. And again, I know I can test this. I click on Start. And the weird thing, instead of typing Python, because when I type Python, it launches me to the desktop app. Well, that's not really what I want. Because what we're going to work in is what's called the idle environment. So if I type IDLE, you're going to see that it pops up in a white shell that looks like this. This is where we want to work. So it's the Python idle environment. So if I look and I go through all programs, and I come down here to Python, NOP, somewhere down here, you'll see that Python 3.6 exists. I have both idle for 16 and 32-bit. Doesn't make any difference. But there's a whole lot of pieces in here. The one I care about is the IDLE. That's the one that we're going to run most of our coding in this particular class. So you need to make sure that you can get to this shell here. So it'll say Python 3-something version shell. If you're in the lab and you haven't updated and it says 3.4, 3.3, those are fine. We're not doing anything that's going to affect. And quite frankly, as long as you're in the 3-something versions, you'll be fine for this class. The latest version is the 3.6.4. That's what we have installed here. And so we're going to look at this particular program then in some detail here in just a second or two. Bless you, by the way, whoever just sneezed. So assignments, if I go to week 7, I'm going to open that up over here. I'm going to move it over. So week 7, this is kind of our odd little transition week. So make sure you've installed Python. You're going to need it for this week's assignment. We have a quiz this week, and that quiz has a lot of content. I do know that I need to update a couple of the questions, but the quiz is over the book material for the most part. There are a couple of questions out of our talking about Python and working with Python. So you'll need to actually look at both textbooks. So you need to have the Python textbook already. And you should have gotten that several weeks ago. I do have to update a question on here, so if you go through there and I have not updated the question, because I will give you a freebie on the quiz, it asks for what is the latest version of Python. I haven't updated that from last year, and I need to remember to do that. So we're going to work in Python. So your assignment this week, so you need to have read the chapter 1 out of our textbook. So the Python, the How Do I Begin with Python textbook. Again, really cheap, really easy, and we're going to look at some of these pieces between those. So we also have, this week we start beginning this week, we begin having discussion boards every week. So from week 7 until the end of the class, you're going to have discussion boards. So this week's discussion board says, from the website at python.org and your own research, including the book, why are we installing version 3.6 when our text says that we're using version 3.1? Why would I have you install the latest version? Are we going to have any problems with this? Why would I do that? So there is a discussion board this week. And as you look ahead, if you look at the discussion boards, there are pieces every week in the discussion board. So make sure that you remember to go in and do those discussion boards. They do add up, and missing them does significantly affect your grade. And then when we get into the coding, one of the things we're also going to do is you're going to start posting your solutions the next week. So in other words, once the assignment is due, then the next week you're going to post your solution to last week's assignment. That way you guys can all look at each other's code and go, oh yes, I see how you did this. How could I have done it? And that way you can gain not only from one solution, but you can see multiple solutions to these problems. So, and what you'll find is that sometimes we'll have a student that will make a far more elegant post than I could ever manage to do. You will start to see that fairly quickly. So we have one more subject we need to cover, and that really is that idea of something called object-oriented programming. So last week we worked on modules. And we said, all right, we're going to break our code up into modules. And that makes a lot of sense. We can reuse pieces of code. And so now we're going to look at something that is kind of an extension of that. And so object-oriented programming is we're going to try to come up with methods or functions that we can take data, and we can take that data, and we don't care what kind of data it is. We write a module or an object, and we don't care if it's numeric data or it's variable data or it's a picture, and it can handle that data, manipulate it the way we want, and return it. So some people call object-oriented programming black box. We're creating black boxes. We don't know what's going on the inside. So when I say like a black box theater, we don't know what's going on inside of that theater. Well, black box coding, we don't necessarily know what's going on the inside of that box every time we send it something. We have created it in the past usually, or we're using a library. So we have to think about this idea of what are some of these constructs we're going to call something. And so we have to think about a class. And not a class like you're in right now, but we call these things classes. And so, if I have a class and I call a class dog. So, we're going to create a class of a dog. We all know that all dogs have similar characteristics. So we know that dogs have an age when they were born. We know they may have a shot status. They may have a hairstyle. We may know all these different things about dogs. Maybe we know how much they weigh. Maybe we know how tall they are. All those things are an attribute of that dog. So if I did the same thing with people, we would know that people have very similar characteristics. So we create this dog. Well, in addition to that, we can also create methods or functions inside of that class. And so if I'm looking at a dog, that function or that method might well be something like eating. It may be barking. In this case, they say running method, eating method, barking method, maybe home defense method. I don't know. It's something that the dog does. So, in other words, not only do we have an attribute, but we have some actions. Well, once we've created that class, then we can create instances of that. And those are what we're going to call objects. So once we create that class and we look at our instances, now we say, all right, so we have a dog named Ginger, 6 years old, a boxer, and their shots are up to date if I scroll through there. And we have Spot, and we have a Dalmatian. So we're creating this class that creates that structure. And then we can create individual instances of that. So the same way, we could create one called people. And people have characteristics, and then we could have instances of people. And we could have a person named Ginger. Don't have a lot of people named Bowser. But we could do the very similar structure. We do that all the time. Here at the college, you are the class student, and you all have characteristics. You have an NUID. You have a sex. You have an age. You have a location because we have an address for you. And then we can create individual instances. When we spin up people, we go, oh yeah, so we have Tom and Dick and Harry and Sally and Mary. And those are all instances of that class student. So it's a little different because it's something we haven't done yet. This is probably the hardest thing to kind of wrap your head around in here because it's new and it's different. So to create one, and this is always a tongue twister, and I can guarantee I will trip over my tongue on it. So you create an object called instantiating. That word. So you create an instance. So once I have that created, that shell, once I create an instance of it, then I have an object. And we can define that class with a couple of different pieces. So we know we have to have a name. You should have some kind of data, although technically you don't have to. So most classes have data, most classes have methods. So the reality is I could create a class that had no data, no methods, and just had a name. But that's not really great form, so I could create a class called student. And then I have different items in that student. So what characteristics do we know about students? We know they have an NUID. What other things do students do? What are common characteristics that every student has? They have a name, major, we know they have an address, we probably want to know if they're, let me define that before somebody, are they male or female? Is there anything else we might need to know about them? So we have their major, their GPA, whether they're male or female. And I would say we have age, but is age really the best thing we could use, or is there something better than age? Related to age. Yeah, and we can put classes in there, but we'll look at it. So if I put in an age, does that automatically update every year? What would be a better way to define how old somebody is? What if we put in their date of birth? Could we calculate their age at any point? So it's just a little better way to do it. So we have all these things about students, and we can figure it out. You know, you could have a parking permit number. So all of those things could be in there. Maybe you have both a permanent address and a local address. So all those things are common to students. But we also can look at it and create some methods. So we know that students do some things, and we can run a method. So a method might be, what methods, what students do, what functions do they do? So method goes to class. We might have a method enroll in class. So all those activities might be a method attend sport ball. So we might have all different kinds of methods and different pieces about them. So now we've defined a class. We have all this information about them. We define things they can do, but we don't actually have any objects yet. So we don't have an object until we create that. And until we put a name and we say we're going to create Mary, and so Mary has an NUID, and we know her major is criminal justice. We know what her address is. So Mary is now an object. We can now, once we've created Mary, she can do any of those methods. She can enroll in class. She could go to class. So whatever methods we have. And we're not limited. We can also have Mark. We could create, in most cases, unlimited numbers of objects. And they all have this similar characteristics. So we create this structure based on being able to create those instances. So this is kind of the overview. So here is several methods. So here we created one called employee. So the employees have a couple of things. They have a name and they have a pay rate. So not a lot of information about them other than, wow, they have a name and a pay rate. Hopefully there's not two of the same names. And the methods they created, so they actually went a little more in detail, and they created two different types of methods. So we know a void method doesn't return anything, whereas a regular method does. So they said, here is our first method, and it's called setName. So now we're getting a little more detail. So this method here, setName, takes in an input and says name equals last name. So maybe we have an input function. Then we have a set pay rate, so we get a pay rate. Then we have a get name and we have a get pay rate function. So now we're getting a little more involved in some of these functions, and what we're going to put in there are those methods that we're going to utilize those. So, a couple things to remember. Even when I declare a class, so if I declare my class student or my class employee or my class dog, that doesn't mean it doesn't create anything. It just creates the form. So if I go back to my database, and some of you I think have had database, this is that structure, that schema, before I actually put any content in there. So this is an application that actually does that. So here we have a start and a stop. So we say, all right, we're going to declare employee my assistant. Okay. So my assistant, and one of the things when we use object-oriented is we use a lot of what's called dot notation. So my assistant dot set name. That dot set name calls the method set name. And the dot set pay rate. So we use that dot notation a lot when we do that. So you'll see we use that quite a bit. So one of the things we have to deal with is these objects are a really great way to contain data and contain information. And so we need to think about whether we're going to set them up as public or private. So we can create both. And by default, most languages really say everything is private. In other words, it's only usable inside of that class. I can move data in and out of it, but it takes a couple of extra steps. And that's probably, for the most part, appropriate. So think about your NUID. We don't want that floating around accessible everywhere. And so we have a private method that we can do that. And so here we actually say, here's our class employee, and here we have fields, and we actually say explicitly private for the name and the pay rate. So we don't want those accessible outside of this particular routine. But notice we also have methods that can be public. So we can access those public methods. The public methods can access the private data. And that's where it gets a little confusing. So we really want our data fields, for the most part, to be private. We want to be able to contain that data. So think about you as a student. We don't want somebody to be able to run a real simple query and get all of your student information. If we did that, you'd get even more junk mail and email and mailings than you do now. So here we've added additional methods. So you can kind of see this is a little more fully fleshed out. Now we have class employee. We've added several methods, and we have private methods that you see down here at the bottom. So a private method, so private, when we talk about a method, that means another method inside of this class can call it, but a program externally can't run it. So if I'm inside of here and I have another method that says calculate pay rate, it can run. So notice here, it runs from this method here. This method calls this method. But I can't call it from my main program if I want to think about it that way. So I'm hiding it behind another layer, and so hopefully that will keep things like my pay rate secret from everybody else. Well, so far it doesn't look a lot different than really using those methods. We could do everything the same way that we've used methods. And in fact, because this is a fairly new idea, there's a lot of programs that don't have any idea about object-oriented programming. So if I go to the bank and they're using software from 1967, this is entirely new to them. They don't get this. But there are some things that make it really, really very useful. And so if I look at the idea of something called inheritance, this is where it gets really exciting. So a class can inherit the attributes of a superclass, if I want to think about it that way. So the best example I have, or that I like to use, makes some sense to me, is I'm going to delete our stuff up here temporarily. And I'm going to say, let's not have a class student. Let's have a class for person. So does person include students probably? And it's got some of the same information. So we know that it's got a name. You probably have an address. So I'm going to strip out all the pieces that are just relevant to a student. Most people don't care about parking permits. So now we have a class person. Well, those attributes are common to really anybody. And so maybe we also have social security. We have eye color. We could come up with several others that are all just related to a person. But I also want to create a couple of classes, and I may never use that class person, but I am going to use class student, and I'm going to say, well, I'm going to inherit person, and I'm also going to create a class employee, and I'm going to do the same thing. So that inheritance says, I created a class student and I just inherited everything from person. So now my class student has name, address, sex, date of birth, social security, eye color. My class employee has those attributes. And if I came up with another class, so maybe I could have class visitor. And they're going to have all those attributes. So I don't have to write them for each one of those subclasses. I know that they have all those attributes. And then I can add those attributes that are only useful in that particular class. So if I take class student, I'm going to add a couple of attributes. So class student then has GPA, major, maybe a minor, whatever it is that's student specific. And if I take class employee, maybe I'm going to take supervisor and put their name in there. And department. And maybe certificates. Because even to work somewhere, sometimes you have to have certificates. And so now I've created that class employee that has all these attributes. So it's got name, address, sex, date of birth, social security, and supervisor, department, certificates. So that inheritance allows me to take from one and bring it down. And it does the same thing with the methods. I could inherit methods if there were methods up there. So this allows me to create then objects based on those superclasses. So superclass is person, and then we have student, we have employee, we have visitor. So another example, if you want to think about it, would be, what if I had class dog? And dog would have our typical attributes like date of birth and maybe color. And then I created a class and I called it class Labradoodle. And I inherited all those attributes, and I could have a class for each breed of dog. And then when I create an instance of that dog inside of that class, it would inherit all of those pieces down. So it's a little hard to wrap our head around, but notice here we do that. We say class salesman inherits from employee. So salesman, because we know that they have some different things that they do, they get all the normal functions of an employee, but they also get maybe a commission in this case, because we pay them different. So we set them up as slightly different objects. So we call these, and one of the things you'll see is different languages use different terms. So that parent class or base class or superclass, whatever you're going to inherit from is kind of our parent. And then we may have a child or the derived or a subclass, whatever makes sense to you. And you may have a fairly lengthy chain. You may have several links in there. So you may have person, employee, salesperson, and then you may even have inside or outside sales. So sometimes you have a fairly lengthy piece in there, and that inherits that. So keeping track of those can sometimes be a little confusing. So what it does, though, we know that that parent class may be well developed. It's used all throughout our coding. It's used throughout our system. And you then, when you inherit it, you only have to add new features or new pieces for what you derive from that. Well, we're going to use these ideas. And so if I think about like games, we're going to find that games in a lot of cases, we inherit those features and they work really, really well. So because we like to throw out some big terms, polymorphism. And so poly really means many and forms. So polymorphism is then, we've written those methods so it looks at the data that you're putting in context. So if you put in a number, it goes, you must be trying to add something to my salary. If you put in a name, it says, you must be trying to add a new employee. And so you're trying to write this code that those projects will work based on context. So in other words, I don't have to write a completely new program every time. So I can write some code that will do something that's based on a system. So here we have one of the weird ideas. So as I get into these classes, so here we have a class that says part-time employee. Because I have a part-time employee, their pay is calculated a little differently than a full-time employee. So full-time employees are going to get overtime, correct? If our part-time employee is getting overtime, we've done something really, really wrong. And so in this case, this function, because it's lower, it's derived from another function, it's going to override the base class. So whatever we have in that last statement overrides. So the lowest one will override the one above it. So this is the same as if you're in CMIS 410 and you're working with web pages, and when you start looking at cascading style sheets, as they cascade down, that's great, but the lowest level can override the level above it. And so in this case, that part-time employee, so it says part-time employee inherits from employee. So part-time employee is a derived class from employee. So it's a subclass. So we know we would have full-time and part-time. And then that method then overrides what was in the employee class. So we can change things as we need to. And that'll make some more sense once we start coding. You'll start to understand, and that'll seem to make a little more sense. So we also have this term encapsulation. So encapsulation really just means we're wrapping up the data and its instructions. So we try to wrap it up so it's both portable, self-contained, and this is an example of that idea of encapsulation. So we wrap all of this up so it's usable somewhere else. So if I look at this program here, so our program is really only this start to stop. And it says we're going to make some declarations. We have a size, which happens to be a constant, employee's size. So in other words, I'm creating an array of employees, and there are going to be 5 of them. Okay. Here we have a get employee data method. So that is, so notice here we say employees sub. So we're creating a loop to populate 5 different employees. And we just run this just like we did before with the methods. So here, employees sub equals get employee data. So that's a method or a function. So it comes down here and says, all right, well, we create a couple variables, enter your name, enter your pay rate. Wouldn't it be great if you got a job and you got to just enter your own pay rate? It's probably not going to happen, but it's kind of a nice touch. Enter rate, and then this set name and set pay rate are methods then to put those in. So here we have this function, and then it returns back up here. It says, okay. And so this loop runs through all 5 employees. Here we set it equal to 0 again, and now we run through it and goes to the display method. So we put in the data, and then we come in and we output all of the data really quickly. So this puts data in, takes data out, and these are very portable. We can use them for several different things. So why do we want to go to this trouble? It looks like we're creating some additional headache. Because quite frankly, I could create 5 employees pretty easily. But if I need 5,000, then it would be a handy way to have that data structure. So objects have a lot of advantages. We create them, and they contain all the pieces. So if I create an employee, it's got all the pieces for that employee. And they're separated from each other. I can manipulate them, but they're like little bubbles if you want to think about it that way. I create all that data in there, and we can manipulate them, move them around, and so it's a great way to do that. So with polymorphism, we can actually put in different types of data, and it can know where to go. So in other words, we don't have to create the module differently for different types of data. We create that module very robustly, and it can handle whatever we put into it. So object-oriented programming is a great idea. And it really is great when we start working with teams. So now we have more than one person creating things, like maybe we have programmers in our system working on the student information system. Well, now, because we have that defined object, we can write modules to interact with it very, very easily. And by using that inheritance, so students could have subclasses very easily. So maybe we divide our students into athletes and non-athletes. Well, they inherit all this information from the normal student class, and then the employee, or the athlete might only have that information then that's additional for an athlete. So things for eligibility might be in there. We might have a class for student musicians. There might be additional pieces for them. We don't have to make the employee class that big because it doesn't need to have all of those sub-pieces in there. And so we can extend those classes really, really easily. And we know that the class above that works. It's already been used. It's functioning. So now we're just adding these small pieces in there to make life a little easier. So object-oriented is not really anything scary or freaky, or it really is taking these same ideas you had. Now you've got methods or functions. Well, now you're attaching those functions into these little objects. You're going to call them blobs. And so one of the best methods I have to kind of wrap my head around it is you've all played video games. And I think of video games as like little marching aliens coming down the screen in Space Invaders. Each one of those is an object. It can do things on its own. It's got functions. It could have a function of shoot. It could have the function of try to destroy you by running into you. So it's a way we could look at the world in that method. So object-oriented isn't really a scary, scary world to look at. So make sure you read that chapter on object-oriented programming. We're gonna do a lot with it when we actually get into Python. Don't save. So we have a couple of other things. How many of you don't have your book in here yet? You guys all have your Python book, I hope. All right. From now on, you will need to bring it into class or have it with you, because now it's going to be your reference guide to where we're at. But there's a lot of other pieces we want to look at. So I'm going to go back to our friend python.org. And maybe I don't understand how to do something. And what I'd like to look at is, well, the jobs function might be interesting, but I want to look at the documents. And so it's got everything from what's new in 3.6, how to install different modules, it's got references, it's got facts. But notice what I see right here. It's got a Python tutorial. And if I look through this tutorial, it's got a lot of different pieces in it. And I will tell you this, we are not going to get through all the material that's even in the tutorial in the next 9 weeks. So you can look at any piece in here. It's not going to scare you. It's going to say, oh, okay. And the very first thing our chapter talks about, and so it very similar to this tutorial, is it talks about something called the interactive mode and the script mode. So I want to look at that really carefully. So if you will, bring up that idle environment. So the easiest way, hit the Windows key, type IDLE. And when I do that, I should pop up a window that looks like this. So now I've got multiple copies of it up. So this mode we call interactive mode. And so I'm going to have you guys print your first statement. You're going to look at your first statement in Python. So it's as simple as we're going to type the word print. Now, notice it changes color. That must be a good sign. It must mean we're doing something right. In fact, you can check it. If I type it with a capital P, notice what happens. Nothing. So one of the quirks of Python is most of your commands or things you're going to do or your functions are lowercase. And notice I said it's a function. Interesting. So what do I always have to use when I'm doing a function? When I have a function in math, what does a function in math look like? How do I know that it's a function in math? So if I do a function in Excel, what do I have to put in there? So if I fire up Excel, and I'm going to create a function, so I create a function. We know it has to start with equals, but that's not the point I'm looking at. But if I do a sum function, what do I have to do to let it know what data goes into that function? How do I know what I'm passing into a function? But if I just type in a number in here, it's going to go, there's something wrong with that. And it's going to hiccup and go, nope. You must have been typing in not a function, but you must have just been typing in some random text. What do I have to do to tell it that I am putting in detail? That parenthesis, or that. So if I open those up, open and close parenthesis, that's what I'm doing. So here I'm putting sum of, so number 1, number 2. Well, the same way with our code here. Almost everything we do is really a method or a function that's already been created for us. We don't have to go to the underlying print statement and create it. It's already there. It's a print function. So if I want to create a print, I'm going to put, and then when I do that, notice it even pops up some additional information. It says print values, I need separators, I can put end statements in there. So print is a function, and almost everything we're going to do in here are functions. So if I want to print my name out, what else would I need to do? So I'm going to just print my name. And when I do that, what's going to happen when I hit enter, do you think? Because this works, this mode, this interactive mode, works one line at a time. When I hit enter, what's going to happen? Try it on your own. I'm curious what's going to happen. Did it work for anybody? They got their name printed out on the screen? What happened? You get an error code. And if I look at that error, because we're going to all get error codes, and it says the name Brad isn't defined. So what it's really telling me is, when I put in Brad, it thought it was a variable, right? And so it doesn't, it goes, oh, nobody defined this variable Brad. I don't know what the heck's in there. What do I have? So I'm going to try this again. So I'm going to type print. But this time I'm going to put my name in quote marks. And notice it maybe likes that a little better because it says, oh yeah, it put it in green. And so if I close my parenthesis, and now it spits out, oh yeah, there's a name. Now, interactive mode is great if I want to try one line at a time. And in fact, I can put in an entire program in here, but that's probably not an easy way to do it. I have to separate each line. I have to put in all kinds of separators. But for trying out one line, so I could try print. So I could even say, so Brad equals. So now I've assigned it the value of Brad. Oh. Well, that didn't really do much, though, did it? So now let's see what if it remembers it. Print. And so it does remember what I've set that variable to. So remember when I said we had all that housekeeping we needed to do? When you write code, you want to make sure that you get rid of values that are in there. It remembered what Brad is. I didn't ever even have to declare it. That's one of the great things about Python, or a bad thing, is I can just set a variable anytime. And now I could use Brad. So I could print Brad, and I could do it again, because it's stored in there. But maybe that's not what I wanted. Maybe I wanted Brad to be equal to a number. So now I've stored 100 in there. I print. And now it's going to print out that variable that was stored in there. So we always want to be really, really, really self-defining with our variables. So what are variable names? We want to be very specific, because if we can self-document those, it's kind of handy. So this variable, or this interactive mode, it's kind of handy. Notice it remembered variables and it stores some data. And so it's a really great testing environment. So you've now created your first program in Python. One line. You made a print statement. And if I look at my homework for this week, go back to assignments, back to number 7. So we know we have a discussion board, but it talks about what are the biggest advantages of script mode. Well, we're using interactive mode, so we're going to have to talk about that. How do I save my program? What are comments and how are they used? Because comments are going to become very important to you. And write and save a program that prints out your name and waits for the user to press the Enter key before the program ends. Well, I have a problem. I'm here. I have Brad. How am I going to write a name in a program? It just sits there and looks at me. And so we're going to have to look at a couple of other features. This is really great. I can create another variable, so I could have one for Tim. So I could say Tim equals 120. And now I could even print Tim. And notice, because it's a function, the print statement's a function, I have to put those together. And I could even do some math functions. So I could say Tim equals Tim plus 120, print Tim. So I can do a lot of, well, that's kind of handy. But I need to be able to write something a little more complicated than that. So the key to this is we can actually write in anything we want to. So I'm going to find my friend Notepad again. Open somewhere. So I can actually write my Python code in Notepad. And so I could write Tim equals 100. Brad equals 200. Mark equals Tim plus Brad. Print Mark. Now, that's my whole program. That's interesting. Let me see what I can do with it. I can copy it, and I could go back to my script mode. Let's see if I can just paste it in there. Oop, hang on. Apparently I forgot to hit the right key. Oop, I made it very angry. Hang on. Let me just start a new shell. Apparently it did not like that at all. Copy. Paste. I could run it. Oh, multiple statements. So this doesn't like me having multiple lines of code. And so I could put it in one at a time, and it's going to remember all those variables and everything, but that doesn't seem like it's probably the best way to do it. But I know I wrote this program over here. Well, if I go up to File, and I click File New. So New File. So now I have a window, but it looks a little different. So wait a minute, what is this? So File New created something different here. And just to save time, I'm going to paste that in there. And oh, it highlighted that. Okay, maybe we're onto something here. So it says it's untitled. So I'm going to look up here at my options. So File, Format, Run. Oh, wait, there's a Run. Hold on. So if I say Run Module, or F5, oh, interesting. All right. So I have some options up here, and I can also get one that says Check Module, and it wants me to save it. So there must be something to this ability here to save a file. So I'm going to click File, and I'm going to click Save As. So you're going to need to find a spot where you're going to save your coding. Flash drive, something else. I'm going to save it in Documents. And I'm going to give it a name. So I'm going to call it Program 1. Now, best case, we don't leave spaces in there. The spaces can be a problem later on, we'll find out. And notice that it says save as type .py or .pyw. So that's the file type it's going to save it as, is a .py. So I'm going to click Save. I'm going to go over here to Documents, and I'm going to drag it over and I'm going to look at it. In fact, you'll see that it looks like program1.py. And if I just click on it, it's going to ask, how do I want to open it? I'm going to click OK, and it's going to do that. It's going to pop up that black box, run the program, and then execute. We don't know if it ran right or anything else. So, a couple of ways to get it to back to our edit mode. I'm going to have to either say right-click, and I'm going to edit with idle, and notice that's now an option. So I can open it with idle this way. So edit with idle, either one of them. I have both a 32 and a 64-bit on here. And it's going to pop back open. Or, from my idle environment here, I can click File, I can click Open, I can then go to Documents. So it really goes the same place, and it opens that up. So this idle environment here has two modes. So this mode, interactive. This mode is what we call script mode. That's where we're going to do our coding for the most part. Now, I'm going to show you other tools because there are some problems with this. It's very plain, and it's going to tell me that, oh, you have an error in line 37 at some point. And I don't have an easy way to even find line 37. But right now, I've saved this, and so I could run this program. So I'm going to run it, run module, or if you remember F5, the same as if you wanted to start a PowerPoint. And notice what it does. It actually runs it over here. It shows me my output here. And my output then says, all right, we're going to start this program. So I'm going to run it again, and notice it runs over here. So now I could change that program. So Tim is now going to be equal to, and I'm going to just put it in quote marks, Tim. And I'm going to have to save it again. Before I can run it, oh yeah, we're going to save it. Oh. I already broke my first program. And it's going to tell me what, give you some help on that error. So it's going to say line 3 in module, Mark equals Tim plus Brad. Type error, must be a string, not an integer, which is what INT stands for. So what it's telling me is, in line 3, 1, 2, 3, I'm trying to add a number and a variable together, and it doesn't like that. So I could count to 3 pretty easily, and I could say, oh, okay, well, let's do put in my name here. Now let's see what happens. And notice what it did. It actually did add those two values together. So we could do all different kinds of pieces in there and manipulate it when we look at strings. So now we wanted to run it again. I modified it just a little bit. And now we put in a space in there. So we could look at that and we can combine variables that way. So you'll start to see that we have some ability to do that. So then if I wanted to get really creative, because we're doing that, so mark equals mark plus mark. So variable doesn't really tell us much in this case. And we can start manipulating text and numbers already. So we could call this one, so instead we could say salary. Maybe you're making $14 an hour. And we could say hours. So white space doesn't count. We can put that in there all we want. Make sure you know how to do. And so then we could say wage equals salary times hours. And instead of printing, we want to print wage. So now we can do math functions in there really easily. So we could say run. And so we know if we make $14 an hour at 40 hours a week, we make $560. And we could say, oh, well, that's kind of fun. Maybe I want to know what my yearly wage is then. So you could even do this, and you could say yearly equals wage times 365. And now you could run this program. So you can start to manipulate and modify just with what we have already. So if you made that every week, somehow you'd, 365 days, huh? So I apparently have 365 weeks in a year. How about we do this? It'd be nice to make $200,000 a year at $14 an hour, but not quite feasible. So you'd make $29,120. So that is that idea of that script mode. So here's script mode, here's the interactive mode. And the key to that is we have to save that program. We can't, just like in your web class, you can't run anything unless it's saved. You can't see the results. It saves everything as a .py. So when you're turning in assignments in the future, you're going to turn in .py files. You're going to save it. You're going to turn in that .py file. I'm going to try to then run that file. If it doesn't run, then we have a problem. But what you're going to turn in then are these saved files. The very first week, I'm allowing you to just copy and paste in. But if you want to turn in a .py file, you are certainly welcome to. But since I'm already making you answer some other questions, I thought it would be easier if you just pasted in your code for that. So this, we save that. Make sure you know where you're saving them. By default, Python will try to save it inside of its own folder. You'll probably want to save it onto a flash drive or somewhere that you can create a folder in My Documents, something like that, where you know where it's at. So be descriptive in your file names. When we look at how do I create Comment tags. Be descriptive in your comment tags. And I'm not going to show you how to do that. I'm going to make you guys read the book on how to do those for Thursday. So that's Python. It's not scary. It's a little set of white boxes. We can manipulate it. We can change it. And it will tell us if we're wrong. It's really, really great. In fact, you can find that if I hit the check module, what is it doing? Didn't seem to do anything for us, did it? So we'll have to figure out what that does and why it does it. I can make changes in, so you can say whether I do want it. You can change the fonts. You can do all kinds of things with it. But most of the time I just leave it in its default. There you'll find there are some other pieces in there. So here's a turtle demo. So Turtle Graphics is hiding in there. We even have the ability to, which one is it going to pop up in? Or is it? Oh, there it is finally. So if I hit Docs, it actually brings up the entire documentation. So things that are what we call deprecated, that are going to be eliminated, things that are removed, what's new, all these different functions. Everything is available there. So help functions are available. There's tutorials. Python is one of the most widely used beginning programming languages. But that doesn't mean that it's not powerful. It can do a lot of functions. So there are programs written in here that are very large. So Dropbox, if you've used Dropbox, is written entirely in Python. We write a lot of scripting in Python in things like security applications. So we can do quick little applications. Companies like Google use Python to run scripts and run programs to monitor their systems. How are things working? And so you're going to find we use Python for a lot of great applications. And it looks like English. I just gave it a value. I said, okay, here's a value. I didn't have to declare it even. I didn't have to say, okay, that's a numeric, that's an integer, it's a long integer. I just said, all right, salary equals 14. If I did this, now I've declared that as not an integer, but as a decimal value, right? So I can save it again. And I'm going to save this one so you see what happens. So now I've declared this as a decimal, this is an integer. What's going to happen when I run it now? Do you think it's going to run? Because we have two different variable types again, don't we? So let's see what happens when I hit run. And Python's really smart. It says, oh, you're trying to multiply those two. Well, I'm going to create, and it's called casting. It's going to put that as a decimal. So to declare it as explicitly as a decimal, I would just do it as 40.00 or 40.0. And that tells Python that it's a decimal. Either way, that 95 cents an hour extra gives me almost $2,000 in a year. Wow. Small increases in wages can help. All right, so read chapter 1 of your Python book. Read the last chapter in the online textbook about object-oriented coding. So remember, the quiz is a combination of both. Primarily, it's questions out of the programming guide online. So it'll force you to read about object-oriented programming. All right, any questions? Let's roll out of here.